The purpose of this video is to introduce you to the concept of composition of transformations. Now, composition of transformation simply involves performing two or more transformations on a particular object. It could be a point, it could be a triangle, could be a pentagon, but anytime we perform two or more transformations, we call that composition. The notation that we're going to use for composition of transformations is a little open circle. And anytime you see that little open circle, I want you to think to yourself the word following. Now, like many of the other ideas that we've covered so far with transformations, often the most difficult part of the entire process is interpreting what we are being asked to do. So, let's take a look at how some of these types of questions might be asked. For instance, we might see the notation reflection in the x-axis following a translation which moves an object 3 units to the right and 4 units up. But what does this really mean? This really means to perform the translation first, and then once the translation is performed, to reflect the object over the x-axis second. Another example of how we might see this might be to say a translation that moves an object 3 units to the left and 3 units down, following a reflection in the line y equals x. So what this really means to do is to reflect in the line y equals x first, and then once we've reflected our object in the line y equals x, to translate it secondly. Whether you realize it or not, you've actually been doing composition of transformation for a while now. When we did a glide reflection is simply a composition of two transformations, namely the translation or the slide and the line reflection. All right, so let's take a look and see how this might look on the coordinate plane. Let's take some point P with coordinates 6, -3. And it wants to know what happens to that point after a dilation with scale factor 1/3 following a reflection in the line y equals x. And then it tells us that the use of the graph is optional. Now, when I go through this, I'm not going to use the graph, but if it makes you feel more comfortable, feel free to plot the point and to graph the line whose equation is y equals x. I'm going to go ahead and start with that reflection across the line y equals x. So if we start with our point P with coordinates 6, -3 and reflect over the line y equals x, I remember that the shortcut for reflecting across the line y equals x is to simply take the x and the y coordinates and switch them. So a reflection in the line whose equation is y equals x is going to land me at the point whose coordinates are -3, 6. Now that I've performed my reflection, I'm going to go ahead and dilate that new point using a scale factor of 1/3. And when I dilate that new point using a scale factor of 1/3, I end up at the point whose coordinates are -1, 2. And that point is my point P prime, the image of point P after a dilation of a scale factor of 1/3 following a reflection in the line y equals x. All right, let's go ahead and flip the paper over and take a look at another one. This one I think looks particularly confusing, so let's see if we can sort this out together. It says find the coordinates of the image of the point whose coordinates are 6, 4 under a glide reflection of a translation in the direction of vector v following a reflection in line L, where v is the vector that moves something 5 units to the left and 0 units up and down, and L is the line whose equation is y equals 1. And then again, it tells us that use of the graph is optional. Well, to reflect over the line whose equation is y equals 1, I'm going to need the graph because I don't have a special rule to reflect over this line like I did in the first example. So the first thing that I'm going to do is go ahead and plot that line y equals 1 on my paper. So the line whose equation is y equals 1 is going to be a perfectly horizontal line that passes through the y-axis where the y value is equal to 1. If you have trouble graphing this line, set up a little table, keeping in mind the fact that the y values are restricted to 1, and the x values can be anything that you want. You'll see that the points 0, 1, 1, 1, and 2, 1 all fall on this line. So now that I've got my line graphed, I'm going to go ahead and graph that point whose coordinates are 6, 4. So there's my graph with the line and the point on it. To reflect across the line, I'm simply going to count. Point P is 3 units above that line. Therefore, its image under a reflection in that line is going to be 3 units beneath that line. So under a line reflection, that point P now becomes that new purple point. Now that I've got my line reflection done, now I have to worry about my translation. So my translation, it tells me, is going to move something, or move this purple point 5 units to the left, up and down, none. So when I go ahead and shift that purple point 5 units to the left, I end up at the point whose coordinates are 1, negative 2, and that is my new P prime. So under that glide reflection, the one that reflects over the line whose equation is y equals 1 and shifts something 5 units to the left, the point who started out at 6, 4 becomes the point whose coordinates are 1, negative 2. Now in example 3, down at the bottom of the page, it wants you to go ahead and it wants you to start each of these problems at point A with coordinates 4, negative 6. It wants you to perform the given composition of transformations. I'm going to say, why don't you try these, remembering that that open circle means the word following. So for letter A, this says a reflection in the x-axis following a reflection in the y-axis. So I'm going to leave you with that thought and let you know that when you return to class tomorrow, the first thing that we'll do is check these 5 problems to make sure that everybody's on board. If we need to then discuss this further, we can take it to the next level and have some further discussion regarding composition of transformations. If it seems like everybody's on board, then we'll move forward in our exploration of this topic.